Until now, we've considered visual ways of looking at our data. We've looked at stem and leaf plots, dot plots, and histograms. Now we'll move into quantitative analysis. Quantitative analysis uses numbers to describe our data instead of looking at a visual representation. For this video, we'll consider measures of central tendency. That is, 3 numbers that tell us about the middle of our data: the mean, the median, and the mode. The mean is commonly referred to as the average, and we calculate it by adding up all of our numbers and dividing by how many numbers we have. So let's start by calculating the mean of this number set. So again, the mean starts by adding up all our numbers. So 10, 6, 4, 4, 4, 6, and 1. Then we will divide by the number of numbers that we have, in this case 7. Calculating that out, that gives us a mean value of 5. Notice, however, that 5 wasn't part of our original set of numbers, and that's okay. The mean just tells us that half of the numbers are before this value, and half of them are after. It's the central tendency of our data. Next, let's consider the median. The median is the number that's exactly in the center of our numbers when we order them from lowest to highest. So that'll be our first step, ordering these numbers. So we go from 1, 4, 4, 4, 6, 6, and 10. The easiest way to find the median is to cross off one number from each side until you're left with only one in the middle. So 1 and 10, 4 and 6, 4 and 6. That leaves 4 as our median. Notice that when we put the numbers in order, half of the numbers occur before 4 and half of them occur after 4. Next, we'll look at the mode. There's no calculations involved with the mode, as it's just the number that appears the most often. So, looking at our data, we see that the number 4 occurs the most often. When looking at the mean, median, and mode, we will often get 3 different numbers for our measures of central tendency. Here, the mean was 5, and both the median and mode were 4. But it's not common for either or all of these numbers to have the same value. That's why, when trying to determine which one is the most relevant to a certain set of data, we have to consider the data independently. So, in this case, all 3 numbers look like they're a good measure of central tendency. We don't have any major outliers here, and our range is only from 1 to 10, so 5, 4, and 4 are all pretty close to the center of that range. However, if we added in a large outlier, for example, 30, let's see how each of these values would change. So let's go through and calculate the mean with this new value. We'll do the same method of adding up all the numbers: 10, 6, 4, 4, 4, 6, 1, and now 30, and divide by our new total amount of numbers, or 8. And we find that our new mean is now 8.125. So we see that adding in an outlier has significantly changed our mean. Now let's see if the outlier has had any effect on our median. Again, we'll put all our numbers in order: 1, 4, 4, 4, 6, 6, 10, and now 30. And we'll do the same thing of crossing one number from each side until we get to the middle. Now notice we have 2 numbers left in the middle. When this happens, the median will be the mean of these 2 numbers. So we'll do 4 plus 6 divided by 2, which gives us our new median of 5. Notice that the median has changed a little bit, but not as drastically that the mean has changed. Finally, let's look at the mode. The mode is the number that occurs most often, and here it's still 4. So, notice that when we added a very large outlier, our mean changed significantly, our median changed a little bit, and our mode didn't change at all. Many people agree that the median is one of the better measures of central tendency because it's less likely to change significantly when you add in outliers. Means, on the other hand, do change significantly when you add an outlier into your mix of numbers.